This blood was now just free to flow around, and it's kept in these little spaces of this big immense cell called a syncytial trophoblast. Here's a baby at 40 days of development. The placenta goes all the way around. Mother's blood would be where the black is out here. Baby's blood would be inside of these little hair-like processes, looks like cotton candy. And these can be considered as being sort of shaped like a tree with all kinds of branches into smaller and smaller twigs. So baby's blood runs inside the tree to the twigs. Mother's blood is like the air blowing through the trees around it. And the surface of the tree is this single cell that is huge if you could flatten it all out. Let's look at the tiniest little twig we could find, magnify it in the scanning electron microscope. I took this picture several years ago. It was the first picture we had through the scanning electron microscope of a placental, what we call a microvillus. And here we see that these little villi have even tinier little villi sticking out, so this greatly increases the surface area. All of this is a single seamless cell that if you followed it out over its whole surface would be like 8 by 10 feet. Mother's blood would be out here. Baby's blood is in a capillary inside. If we cut the end off there and then look in from the end, this is mother's blood out here, and these red blood cells are baby's blood. And this is the surface of a little twig of that placenta. So things must go from mother's blood to baby's blood right across that barrier. Now, oxygen goes back and forth freely. Carbon dioxide goes back and forth according to a concentration gradient. Water goes back and forth freely. Now, there's some things we wish didn't go across freely. Alcohol from the mother's blood can go across directly into baby's blood. Women who consume large quantities of alcohol can have a baby born with fetal alcohol syndrome. Recreational drugs can go across this barrier. Women who take cocaine can have babies born that are basically crack babies from birth. The sins of the parents can truly be visited on the children, can't they? So this is a marvelous, seamless barrier, but some things can get across that can be harmful. Other things can't get across unless you have a carrier molecule. For example, a baby needs iron. It gets the iron from the mother's blood, but iron will not go across this seamless cell. There's a special carrier protein called transferrin that carries it across, and there are hundreds of these carrier proteins that are absolutely essential for survival of the baby that carry these products across. Just to come up with any one of them, like transferrin, would go beyond the probability of anything you could imagine in the whole geologic timescale. This is the way the placenta looks at term. The baby's attached out here to the umbilical cord. It has one vein and 2 arteries running in it. And there's a jelly around here. It's called Wharton's jelly, whose function is to keep the vessels from getting kinked as the baby is doing loop-de-loops and wing-overs inside the mother. The arteries, you can see them here, and the veins are literally truncated, and so the blood is flying out sort of like, if you consider these to be these little trees I was telling you about, the trunk is here and the branches are hanging down, they're upside down. It's sort of like taking a hose and going up to bushes and just spraying right into the bushes. Baby's blood would be inside the limbs of this tree. Mother's blood is outside. There's about 20 of these trees in the placenta. They're called cotyledons. And when the placenta is at its maturity, there's about a half a quart of blood being released into the placenta every minute. Now, when the baby's born, the baby emerges first, and then the mother emerges after the baby, or the placenta, sometimes the mother. The placenta comes out as the afterbirth, and it literally unplugs from the uterine wall. When it does, approximately 20 arteries, a little smaller in diameter than lead pencils, are severed. And it's losing blood at a rate that in 10 minutes, all of the mother's blood will be exsanguinated. Anyone see a problem here? It's bigger than what you're thinking. The blood clotting mechanism is actually shut down in this region. So let's back up and consider the whole story. We have a hemophiliac with 20 severed arteries bleeding at a rate that will remove all of the blood in the body in 10 minutes. See any problems now? The Lord better have an absolutely astounding miracle in place, and He does. There is a muscular sphincter on each of these arteries and veins, and as soon as the placenta breaks loose, those sphincters close down, and in a normal birth, no more than about 2 cups of blood would be lost. Boy, I'll tell you, there's the biggest whew of them all. If you're an evolutionist, you have to look at that and say, incredible stroke of dumb luck, because you have nothing else to look to. Evolution knows nothing about planning, nothing about solving problems, meeting objectives. It's differential reproduction, that's all. Well, we're kind of running out of time here. I'm going to skip over some things on the recapitulation story and what have you. And you'll be interested in this. I actually have the first picture taken of Ken Ham. It's unreal. This is absolutely the earliest photo taken of Ken Ham, actually in the womb. Well, in the interest of time, what I'm going to do is I'm going to skip over all the marvelous development of the organs of the baby's body. Within 2 months, you have the baby pretty much put together. And at 4 months, we don't call it an embryo, we call it a fetus. And every organ is basically complete. It just needs to mature during the remaining gestation. And I have some very good news for you. In the case of the baby we're talking about here, it went to full term. It's in the right position. The umbilical cord didn't get kinked or anything. The baby's healthy, but I got some bad news. Have you heard about the guy that built a boat in his basement and didn't measure the door? That's the problem we have here. This baby is not going to fit through the birth canal. And it's not just soft tissue problem, it's a hard tissue problem, because you see, here's the female pelvis. It already is uniquely